All right, our last section is going to be on electricity, and I'm going to introduce electric charges today, and we'll see. So, electricity, people, had questions about electricity for a long time because they found some things that if you rub two things together, sometimes they had properties that were hard to explain. So, like, if I take this balloon and I rub it on my hair, then I find that it can pick up little pieces of paper, or things are attracted to it. So they tried to figure out what that was, and we'll see. So today we'll talk about electric charge. We'll say, okay, when I start out, my balloon has, does my balloon have a charge? Like if I just blow up a balloon, does it have charge from the beginning? So I blow up a balloon. And I'll see, is that the same thing that I see happen here? No. How come this time nothing happened? So something happened between when I had my balloon at first and when I had a balloon that I rubbed against my hair, right? So we're going to see, how did it go from no charge to charge? Okay. So maybe the first thing that we should ask is, does it have no charge? When this starts off, does it have no charge at all? We'll say that it is neutral, not positive, not negative, but it does still have charges inside of it, right? So why is it that matter, like this balloon, has charge at all? It's got positive parts and negative parts inside of it. If you think back with me, this balloon is made of rubber. Rubber is made of molecules. Molecules are made of atoms. What are atoms made of? Protons, neutrons, and electrons, right? So this has lots of positive protons in it. It's got lots of negative electrons in it, and lots of neutral neutrons in it. When it is neutral, it doesn't mean that there's no positive and no negative inside of it, but it means that the positive and negative are balanced. There's the same amount of positive protons and negative electrons, so they cancel out their charge. And that's the typical way we find most substances, is neutral. Okay? So then, if I take this and I'd like to mark it, so I'm going to mark the spot where I rub this balloon on my hair. And I'm going to stick it on a string here. Okay. There we go. Whoa. Okay. So right now, it looks like this balloon is attracted to my hand, right? And where's the spot that's attracted most? It's that spot where I rubbed it on my hair. That dot is showing the spot where I rubbed it. And so that's the spot that's most attracted to my hand right now. Okay? So, does that mean that my hand... So, this balloon got charged with a negative charge. How is it that it went from a no charge, a neutral, to a negative charge like this? Okay. I rubbed this on my hair, and after I rubbed it on my hair, what happened to my hair? If I tried that again, you might see Is it attracted to my hair? Sure it is. So my hair and the balloon ended up with opposite charges. So my hair had lots of protons, neutrons, and electrons too. But for some reason, when I rub these two things together, lots of extra electrons like to stick to the balloon. So extra electrons that used to be in my hair end up in the balloon. And then this balloon ends up with a negative charge because it has extra electrons. My hair ends up with a positive charge because it lost a bunch of electrons. Okay. And then let's take a look and see when we have two things that interact with each other. So I've got another balloon here and another little dot. And I'm going to stick these on the strings. When I stick these on the strings, I want to see what would happen if I charged up two balloons. So I'm going to take two balloons, rub two balloons on my hair, and then let them hang down here. So they hang down straight from these strings, right? Okay, so now if I rub two balloons, let's see what happens now. It looks like they're trying to push away from each other. And they're both attracted to my hands. They're pushing away from each other. And what's the spot that's the furthest away from the other balloon? It's that spot where I rubbed it on my hair. One dot's over here, one dot's over here. So those spots that are the most charged are trying to get as far away from each other as they can. So they're both negatively charged, and if they have the same charge, they want to repel each other. So we can measure the amount of charge that an object has using the unit of Coulomb. So far, when we studied physics, we found everything we could break down into meters or seconds or time. And this is the first time we get to something else where we have to add another. So electric charge in coulombs is another SI unit that is separate from these and can't be described from those three that we described everything else with. So if we have two things with with the same charge, they're going to repel each other. If I can get something with the opposite charge, then it attracts. Excuse me. All right. Okay. And since protons and electrons have the same amount of charge but opposite charge, then everything that gets charged is going to be some multiple of that standard unit. So you can have two extra electrons, you can have one extra electron, but you can't have 1 3/4 extra electrons. So it's always going to be at a certain interval. That amount of charge of one electron is very small, but then added together they can make huge effects, lightning or balloons sticking to my hand, right? All right, so I have a few questions about electric charge, but this was some of what I wanted to share with you today.